So let's continue our discussion on firearms examinations. Exactly what can be learned from firearms evidence? We can first determine the caliber and the manufacturer of the exhibit. We can also at times determine the manufacturer of the firearms that may have fired an exhibit. We can at times determine if a particular weapon fired a projectile. And finally, we can determine if a cartridge passed through the action of a weapon. So to do this, the firearms examiner is going to deal with class and individual characteristics. A class characteristic is an intentional or design characteristic that would be common to a particular group of items. So say, for instance, when taking this into consideration, a firearms examiner might have the overall caliber or gauge of the projectile being a class characteristic. The particular number of lands and grooves or the direction of the lands and grooves twisting is also going to be a class characteristic. The degree of that twist and also the width of the lands and grooves would also be considered class characteristics. So then what exactly gives us the individual characteristics? These are going to be marks that are produced by random imperfections or irregularities of a tool surface. So for a firearms examination, this is going to involve changes to the rifling impressions, striated action marks, or at times impressed action marks. For a projectile, a closer examination needs to be done to actually see all of these rifling impressions. The imperfections on the inside of the barrel are going to leave microscopic striations and scratches on the projectile as it passes through the barrel. So we want to take into consideration the striated action marks and the impressed action marks. Striated action marks are the scratches that are produced as the cartridge case moves laterally against the barrel. Impressed action marks are the result of sufficient impact by a portion of the firearm causing impressed or indented marks. So some examples of striated action marks would be chamber marks. These are scratches that are produced by the walls of the chamber as the actual cartridge is loaded into the chamber or removed from the chamber. Another striated action mark is a shear mark, which is a scratch that results from the movement of the primer area of the cartridge against the firing pinhole. There are also firing pin drag marks, which are scratches that can be produced as that firing pin drags across the cartridge case as the barrel drops. Or extractor marks, which are scratches resulting from the extractor hook removing the cartridge from the chamber. There can also be ejector marks, which are scratches created as that cartridge is ejected from the chamber. There are also the impressed action marks, which are usually either firing pin marks, breech marks, or ejector marks. Firing pin marks are indentions that are produced when the firing pin strikes the primer. Breech marks are impressions resulting from the head of the cartridge striking the breech face of the firearm. And ejector marks are indentions creating as that cartridge is ejected from the chamber. So during an examination, the examiner is first going to determine the class characteristics of that evidence itself. If the class characteristics are consistent with the suspected firearm, then test fires are going to be made using ammunition. Usually, there will be several test fires that are produced from a weapon so that they can ensure that that firearm is going to consistently produce unique markings. So the firearms examiner is going to take the weapon, use the known ammunition, and take several different test fires and then compare these projectile or casings prior to any comparison to a sample that was collected from a crime scene. All of these comparisons are done on a comparison microscope that is a stereo microscope. This is your lower magnification. This comparison stereo microscope allows two items to be viewed at the same time because of the presence of an optical bridge. So instead of seeing the projectile individually, they can see both projectile at the same time in one field of view. If they find that from the test fires there are unique and consistent markings, then they can go ahead and compare it to any of the evidence items. So at that point in time, the evidence item would be mounted on one side of the comparison microscope with the test fire on the other side. This shows you a good example of a rifling comparison. And this shows ejector marks that might be present. This is a firing pin impression and various breech marks. So you can see there's a lot of different impressed areas or scratches and striations that can be used by that firearms examiner to compare items collected from the crime scene to known samples or known weapons. In some instances, though, it might not be possible to have that known weapon or the known ammunition, and at times like this, the firearms examiner may be able to take advantage of a database. In the past, there were two databases that were used, one that was primarily produced through the FBI and another that was produced by the ATF. However, in 1997, both of these efforts were combined, and they created the National Integrated Ballistics Information Network. NINBIN digitally captures images of fired bullets and cartridge cases from criminal investigations and also from test-fired samples from recovered weapons. The database itself collects a lot of images, and then they can be matched to possible crimes. With the use of this database, the firearms examiner can link investigations and jurisdictional boundaries. There are currently about 182 different agencies that use the database, and there are currently over 1.25 million pieces of evidence that have been entered into this system. So in a lot of instances, when that firearms examiner is working with a projectile, they may come upon a hit in the system itself. And once again, like all of our other databases that we can take advantage of, that firearms examiner must validate that match. So they can obtain the known samples and actually compare it to their particular evidence from their crime scene. Firearms examiners also perform tool mark examinations. Remember, we said that tool marks are created when a tool comes in contact with a surface that's going to be a softer surface. So it's going to impart an impression or a scrape. In this situation, the actual tool marks are going to be created by tools that create some type of a mechanical advantage. And the tools are going to be divided into groups according to their working action or their mechanical advantage that's actually obtained. You have compression tools that use some type of a compression action to compress by pressure or impact. So the most common of these is going to be a hammer. There are also crimping tools that have two opposing jaws designed to bend or to crease materials and provide a type of a gripping action. So the most common of these is going to be your wire crimpers or your vial crimpers. Another common tool is a screwdriver, which displays a flat mechanical advantage or a flat action. These tools employ a flat blade to work the desired action. So things such as tire tools, pry bars, and screwdrivers. And also there are gripping tools. These are going to impart a squeeze or hold onto the object by opposing jaw design. So the most common of these is going to be your pliers or different pipe wrenches. There's also tools that have a shearing action that have two blades on adjacent planes that pass each other and are designed to cut. And also pinching tools that have opposing jaws that use a pinching action and are designed to cut. The most common of these is going to be your wire cutters or your bolt cutters. And then we also have a slicing tool that imparts a slicing action using a blade or a cutting surface that moves in the direction of the cut. So things such as knives, switchblades, even wood planes can be considered slicing tools. The working action of the tool also defines the design of the working surface. The particular shape of the surface is produced to obtain the intended mechanical advantage. So our tools are going to have a variety of working surfaces. So this must also be taken into consideration in a tool mark examination. A tool that is going to provide that compression action is only going to have one working surface. If you think of a hammer, it just has that face of the hammer itself, so there's only one working tool surface. However, there are tools that have 2 or 4 working surfaces. The tools that have 2 working surfaces are those that are going to be providing your crimping action, the flat action, or your slicing action, while those with 4 working surfaces are going to be providing shearing or pinching. Just like our firearms impressions, tool marks are also going to have class and individual characteristics. So the class characteristics that we think about when we're talking about tool marks are actually the working action itself. Whether or not it's a compression, it's a crimping, it's a shearing, or it's a slicing, for example. Also, another class characteristic is going to be the size of that working surface. For example, two different flathead screwdrivers. Both of them are going to have the same flat actions, but at a different size. Or another example, scissors or pinking shears. Both of these display shearing actions, but to a different size. But these are all still considered class characteristics. There are subclass characteristics that are produced through the machining or the manufacturing process. Tools will usually have very small irregularities left on them by finishing processes. So this might be something like buffing, scratches that are left after a tire tool is painted, or a rough edge that isn't completely filed in that finishing process. The shape and pattern of these irregularities may also be modified by wear and damage to the tool itself. And this is the more common form of your individual characteristics for tool marks. These individual characteristics that occur by wear can be through normal wear, or it can be through misuse or abuse of the tool itself. So if a flathead screwdriver is constantly being used, those edges might start to become slightly rounded. Or using that same flathead screwdriver, if we abuse it or misuse it and use that screwdriver to pry things, a portion of that flat head may end up actually chipping or breaking. So you can create individual characteristics to that tool through either normal wear or the misuse and abuse of the tool itself. Tool mark comparisons are performed very similar to firearm comparisons in the fact that test patterns will also be made. If the test patterns that are produced by a tool are once again very unique and consistent, then they can be compared to evidence items. And this is also going to be performed with the aid of the stereo microscope that is a comparison microscope. So this is an example of a tool mark comparison. You're also usually working with scratches and striations. And another example. Both evidence types, either firearms or tool mark evidence, have been accepted in courts for many years. When a firearms comparison has actually been performed, the firearms examiner can reach several different conclusions. They can determine that an exhibit was fired from a particular weapon. In some instances, they might determine that the exhibit could neither be identified nor eliminated as having been fired from the weapon. They can sometimes determine that that exhibit was not fired from the weapon, or they can sometimes determine that the exhibit was identified as having passed through the action of the weapon. In regards to tool mark comparisons, they can usually reach one of three results: that that exhibit did in fact make the tool mark, or that it did not make the tool mark, or that the exhibit could neither be identified nor eliminated as having made that tool mark.